Has anyone seen Mark? Because I am not qualified to MC alone. There is just, it's not...
Are you looking for me?
Wait, what? Has anyone seen Mark?
Mark's not here, he sent me to fill in. I'm the MC they need, not the MC they want. Weren't you supposed to be Robin?
You thought that was serious?
I thought that was serious. Really? You're not? Well, my face is red. You can't see it, but it's he was supposed to be Robin!
I'm not Robin.
Okay. With that said, I guess I should introduce our next speaker. By the way, this is really hot. Yeah, exactly. I'm Batman. I just like saying that. I've been practicing that for weeks. So our next speaker is Kyle Erf. And Kyle's fun fact, apart from not being Robin, it's actually Steve's, is he is a master of the keytar. The keytar. Yeah, exactly. So Kyle, take it away.
All right, thank you. This is great. This is the first time I've ever been brought out by a billionaire.
An eccentric billionaire at that.
First of all, guys, keep it going for GoBridge. That is an incredibly important cause. It's an awesome thing that is here. So this talk is called Boring is Beautiful, and basically what I'm going to be talking about is sort of about Go as a language and sort of the patterns that work best, and how those patterns that will work best for you will probably not be especially exciting, and ultimately that's a good thing. A little bit of background on where I'm going to be coming from. I've been working at MongoDB for a little over 2 years here in New York City. I'm on the server tools team, which is a team that writes almost entirely in Go. So I've been programming Go full-time for a little over 2 years. And in that time, we've seen like growth among Go's use in the company, as well as just on our team. And as part of that, as part of being on the server tools team, I've seen a lot of new hires come and start to pick up the language. I've seen a lot of people come to the language from languages like C++, and I've also had to give workshops within the company on how to use Go. And that has given me a pretty decent perspective on the sorts of things people do when they're starting out versus when they're 1 or 2 years in, and what works best when you're writing software in Go. So this talk is going to be a little bit of an opinionated philosophical rant and a little bit of a sort of post-mortem. I am so sorry. A little bit of a post-mortem. Post-mortem lesson number 1, turn on caffeine. Okay. So what I want you to walk away from this with, this is sort of what I've seen good code to be in the actual workplace. Good code is not the code that's the most interesting or clever or cool or even the shortest code that gets something done. Good code at your job is code that is easy to understand, it's easy to work with, and it's easy for people to replace. And I actually do believe in, I think if you read stuff or listen to talks from the architects of Go, this is basically the philosophy that Go was written with that in mind. You know, and Go is like, I think one of the best things about Go is that there's usually only really one correct way to do something, because that lets you focus on getting things done. And if you try to avoid that sort of nice, simple, like good way to do that, in my experience, and the experience of the company I work for, that is going to cost you eventually. Now, some of you may think, like, I'm clearly like a little younger and probably less experienced than many of you here. Some of you probably have decades more engineering experience than I do. So I want to appeal to, I guess, a higher, like more wise, older authority on software development to sort of make my case here. So the first sort of stage of development I want to talk about is this a 2,000-year-old Taoist philosopher, Zhuangzi. And you know, he was from a time before there were things like computers or software or machines or really anything like that. But I think what he has to teach us about it, about work, like about craftsmanship, is actually pretty useful. Specifically, there's this parable attributed to him called the dexterous butcher. We're going to try and think about this as if it's the dexterous software developer. You can make your own punchline based on the title. I'm not going to be so indulgent as to read this whole thing, but I would like to give you the gist of it. Basically, it's a parable about this lord, and he has this chef who works for him named Cook Ting. And Cook Ting, one day, he sees Cook Ting sort of butchering this ox in just this incredibly fluid, beautiful way. He's just incredibly skilled, and it's amazing to watch him do this job. So his master asks, wow, how did you get to this point? And the cook responds, what I care about is the way, which goes beyond skill. When I first began cutting up oxen, all I could see was the ox itself. After 3 years, I no longer saw the whole ox. And now I go at a sprint and don't look with my eyes. Perception and understanding have come to stop, and spirit moves wherever it wants. I go along with the natural makeup, striking the big hollows, guide the knife through the big openings, and following things as they are. So I never touch the smallest ligament or tendon, much less a main joint. He goes on, a good cook changes his knife once a year because he cuts. A mediocre cook changes his knife once a month because he hacks. I've had this knife of mine for 19 years, and I've cut up thousands of oxen with it, and yet the blade is as good as though it had just come from the grindstone. Whenever I come to a complicated place, I size up the difficulties, tell myself to watch out and be careful, keep my eyes on what I'm doing, work very slowly, and move the knife with the greatest subtlety until flop. The whole thing comes apart like a clod of earth crumbling to the ground. I stand there holding the knife and look all around me, completely satisfied and reluctant to move on. And then I wipe off the knife and put it away. Excellent, says his master. I have heard the word of Cook Ting and learned how to care for life, or how to care for your code base. One of those. So, you listen to that fun story. It's a very influential thing that I keep in mind throughout my career. But you might still be wondering, like, what does that have to do with code? So, maybe that was too distracting to put in. Okay. So the way I see it is, most programmers, we are just seeing like the piece of code that we're working on. We're seeing the whole ox, as it were. We're just seeing the one ticket or problem we are trying to solve. And you know, that is a way to get things done, but I don't know in the long run if it's the best way. What I've noticed in my years in the industry is that the people I consider the best programmers are the people that actually see all of the facets and implications of the code they were writing beyond just the literal computing problem they're trying to solve. These are considering things like, what will this code make sense to someone who sees it a year from now? How easy would this code be to change? Well, I remember how it works a year from now. Stuff like that. And it's much more akin to the experienced butcher who no longer has to sharpen his knife because he's learned how to move with the flow of software development. So that was all very lofty. I'd like to turn now to some actual, real, tangible examples of where we've seen our attempts to sort of hack at the code base with a dull knife going awry, and ways that we've been able to sort of rectify that by just using simplicity. The first of these is an example of, it's a little egregious and a little obscure, but I think it illustrates the sort of concepts I'm talking about here. We have a lot of C++ programmers at MongoDB who are very good C++ programmers, and some of them try to take up Go and move patterns from C++ to Go, including sort of the concept of destructors. I'll get back to that in a moment. So we had someone at one point try to use a finalizer. Some of you know what this runtime finalizer thing is. Many of you don't, and that's like probably a good thing. This is actually a very hard thing to find information about, and if you Google runtime.setFinalizer, most of your results will be mailing list discussions about whether or not this feature should exist in the runtime package. But basically what setFinalizer allows you to do is you give it a type and then a function to run against that type when it's picked up by the garbage collector, which is like, that's cool that you have that feature. I believe it's used in the standard library for this os.file essentially, so that if your file gets garbage collected, you don't leave this sort of file handler stuck from the operating system, it's an elegant way to handle something like that and make things a little user-friendly. But it's not something that you should use in your code for a few reasons. In this example here, and the example where we had an employee doing this, a very new Go programmer doing this, they wrote an object that was very sort of buffer-like and had this. You needed to flush it before before taking it out of memory. And there's lots of reasons why doing this with a finalizer is bad. First of all, you're depending on the garbage collector implementation, which, as we know, changes between versions and isn't really something that you can have a good handle on. It's pretty much impossible for anyone looking at your code to reason about it if you were to use a finalizer like this. And perhaps more importantly, this finalizer isn't going to get called if your program just exits, even if it's a successful exit, because there's no point in cleaning out all of your memory if your program's just terminated. So if you were depending on flush being called as they were trying to in this instance, it's not going to happen. It is kind of cool though, right? Like, it is kind of neat that you can do that. But this is the real solution they were looking for. Just use defer. You know, just use the simple things that are given to you by the language. You can certainly make this a close and flush method, and then you'd only have to defer one thing and simplify it a bit more that way. But this is a lot easier to understand. I think we can all look at this and see what it does and see, and imagine when it's going to get called and reason about it. And that's a heck of a lot easier for you and the rest of your team. Moving on to probably the most common misuse of, the most common thing that I see new Go programmers do, and this has been mentioned a couple times today already, is just the use of unnecessary concurrency within their code. And this is sort of understandable why a new Go programmer would try to make just about everything concurrent, because if you go to the Go homepage, this is sort of how we market the language, right? Like, you see all these examples of these really cool parallel concurrent algorithms, or look at how effectively you can generate all these digits, or all of these prime numbers and stuff. But, you know, in your day-to-day job, you probably don't need to write the Civ of Aristophanes. It's not going to come up. And let me know where you work if that has come up, because that's really cool. But basically, you see a lot of things like this where people will spawn off Go routines just to do very, very basic processing, stuff that isn't especially CPU bound, stuff that isn't IO bound, stuff that doesn't wait on blocks. Just very, very basic tasks. And in some cases, I'm sure the overhead of the channels in the Go routines actually slows your code down. For most cases, this is what you should start with. Just a simple, use a for loop, something like that. It's much easier to reason about. You don't have to deal with concurrent execution. It's very easy for everyone to keep in their head. And only if this is not good enough should you resort to breaking things up into Go routines. There's a link here at the bottom. You can pull it from the slide. I don't expect you to type this in. This was an article on the Go mailing list maybe a couple months ago that had a bunch of interviews with Go experts on what's some good advice for Go newbies. And I think avoiding using too much concurrency was essentially the number one thing, the number one suggestion from Go experts, because it's such an easy trap to fall into when you're starting. Now, before I move to the next couple of examples, I'd like to refer to a much more recent sage that will help guide us through seeing why the next examples are bad. This is not a 2,000-year-old person. This is Brian Kernighan. Everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? And yes, that's very true, and we've learned it the hard way. Specifically, when you run into stuff like this, it's often due to abuses of reflection or the empty interface. If you're not familiar with reflection, the Go reflect package is basically I guess maybe along with the unsafe package, is sort of the main way to use magic in the language. It allows you to just manipulate values sort of regardless of their type, or manipulate types in just very abstract ways, and just sort of manipulate inputs based on their types. The empty interface sort of goes along with that. The empty interface is an interface that has no methods and so is fillable by anything. You can see in this example, Whereas you can assign it to an integer, you can assign it to a string, you could, any sort of struct, any sort of function, it can basically be used for anything. And in tandem, you can write some really, really cool, clever code with that is very, very hard to understand. So this is an example a lot of you are probably familiar with from the community. And we actually did use this on an application that I worked on at Mongo. This really popular web framework called Martini, which lets you quickly, the whole point of it was to let you quickly set up routes and really quickly get a web application up with a very simple API. You just sort of give it a function of any return values or any parameters, and it would figure out what to do with it. And in some ways, this is really slick. So for Martini, in this example, you can give it a function that returns an integer and a string, and the integer it will interpret to be a HTTP response code, and the string will just be sort of the content of your reply. And of course, you could omit the integer, and it would still know to just use the string as the content. It uses reflection to figure out stuff like that. In the second example, as parameters, it is automatically detecting that you're using an HTTP response writer and a request, and it fills those in the function for you, like it injects the parameters for you. And you can, of course, set up custom middleware for injecting your own sorts of parameters based on the types of your functions, which is really slick and really cool, and it was really hard for everyone to figure out how it works when we had to onboard them onto the project. This is really beneficial because it gets you up quickly, but once your code base becomes too big for one person to really get all of the HTTP stuff in their heads, it can become very, very unwieldy because it's not clear how to find where, say, your injected variables are really coming from. And the Go community at large and the author of Martini did acknowledge this. And what it should be, frankly, a much more precedented thing of someone responding very respectfully to criticism and working with it. Jeremy Sands, I'm probably saying his name wrong, I'm sorry, Code Gangsta. He actually responded to a lot of the criticism around Martini, saying I was a very young Go developer, and many of us were, and that's definitely true. We were very young when we also thought Martini was like the best solution for us. Martini allows you to inject all the things, and that leads to a level of indirection that, while modular, requires a certain amount of cognitive overhead to fully understand what is actually going on, which is sort of exactly the issues we were running into on my team. But also in his response, he released this great middleware package called Negroni, also named after a gin cocktail, which is much more strongly typed and just is a much more focused library, and we actually use that now, and I feel a lot of people have made the switch from Martini to this new library. And that it's a lot more simple, and it's just a lot easier to reason about. Finally, this is a interesting use of reflection from within our code base for a CI tool we built at Mongo. Basically, this probably needs a bit of background. We wanted to add some REST API endpoints to this application, and the structures or sort of the models that those API endpoints used needed to be slightly different from the models used in the actual logic and database code of the application. This is just like one or two extra fields, mostly as a convenience to the end user, so that they didn't have to do any sort of extra processing on their end. The problem is, like, some of these structs had maybe like 10 to 20 fields in them, and we were maybe a little too lazy to just copy all those fields manually in 10 separate lines. So what we did is we wrote this package called Angiere, which used reflection, this really cool thing you can do with reflection, where you look at the individual fields of the input structs, and then we would copy over data from any matching field to another matching field, allowing us to do sort of an initial copy between two distinct types in one line, which is like pretty cool. Like, it's a really neat trick. But it ended up costing us, and everything sort of falls apart when someone has the nerve to change a field name. So you can see this example, say, change field B in type 2 to X. All of a sudden, now our transfer by field names function is not moving that number from B to X, and our REST endpoint just isn't producing all of the values that it should. And especially if you're not the person who wrote that endpoint, this is a very hard thing to, if you're not in the right frame of mind thinking that we're using this transfer by field names thing, you're not going to be able to figure out what's going on very, very easily. Like, you changed a field name and now the API is broken. That shouldn't happen. It's Go. So we came to our senses. There are better ways to just do this, you know? Just be verbose. It's okay. It's not pretty, but like, this is what Go is all about. You know, you just assign things directly. I know it's silly when I have to say it out loud. It actually is. It's very silly. When you have to just assign things directly, it'll take you maybe a couple more minutes to write all that out, but it's way better than the 2 hours that your team is going to spend figuring out why, like, your REST API is broken because they renamed something. Another alternative you could use is embedding, which would basically save you from even having to update 2 field names at once if you wanted to change one. And finally, and most embarrassingly, you can just use assignment if they're the same type. When we were removing this package from the code base earlier this year, there was actually a spot where we were using this transfer by field names between 2 variables of the same type. Just like a waiter bringing you your salad leaf by leaf. It doesn't, it's not a good use of time. But that does tell us something about sort of magic operations, though, which is that, you know, once you're used to using all this magic, it's hard to stop, and you start using it even in the places where it wasn't really going to help you. It's not a good mindset to get into. So I went over these examples, and you're probably thinking, and just sort of these solutions to the problems presented in the examples, and you might be thinking like, wow, that's pretty boring. And I agree with you. It is quite boring, but I think that's a good thing. I think that's what this language is all about, because boring code is exciting for your team. It might not be exciting in the moment, but in the grand scheme of things, boring code is actually a really powerful thing for you. You know, boring code is easy for you to understand. It's easier for your team to understand. It's easier for your team and you to change. And even if you're going to be totally selfish and not care about your team, writing simple, unexciting code is great for you because then you can forget about that code and not have people ask you about it because they understand it. Ultimately, keeping things simple allows you to focus on what matters, which is not writing beautiful, cool, awesome-looking code that does a really neat trick to save a couple of lines. It's about writing software that does stuff. And that's exciting. All right. Open the floor for questions, I guess.
Okay, thank you, Kyle.